So your exam is due tomorrow night. I've also extended your homeworks, including the two new ones that we covered last time, and we'll probably cover up to 3.3 today. Do you guys have any questions about? Yeah, so you're allowed to use your notes, scientific calculator or graphing calculator. You can also use that website, Grapher. But if you guys have any questions, let me know. If not, I'm gonna start three. I'm gonna go over 3.1 just in case you forgot, and then I'll move on to 3.2, 3.3. Okay. All right, so just I'm gonna try to make it a habit that I talk about what we mentioned last time because it's been a few days, right? And I'm sure you've been more focused on chapter 1. So functions last time. First thing we talked about was functional notation, right? We mentioned how if f of x is the function, let's say 2x plus 2, f of 2 meant plugging in the value 2 wherever you have an x. Right? That was one of the big things we talked about. 2 times 2 is 4, plus 2, 6. We also talked about the definition of a function. We said every input has only one output. Then we talked about graphically, vertical lines touch the graph at most once. For each x. But yeah, if you draw lines through it, it should only touch it once. So that was the other big thing. Just a quick recap here. Third thing was difference quotient. So given a function, find the difference quotient. Oops, QU, not QLU. So that was the formula here. F of x plus h minus f of x over h. And I showed you about 3 or so steps on how to do this. You guys remember last Thursday? So that's what we did. Hope you recall. So we're gonna move on to 3.2. The name of it. It's not too bad. What they do is basically they assume you know what all the graphs look like, which you don't have to. As long as you can use your grapher or connect graphs together, you'll be fine. So graphs of functions. Okay. Let me find some problems. So the first thing, or the main thing from graphing, you guys need to know what all the parent functions look like. Have you guys, did I send you the parent function PDF? I don't recall if I have. Here's a picture of it. So it helps to know what they all look like, but again, you don't have to. You can use graphing utility to help you out, but here's the hard part, I guess. So these are called piecewise functions. So all you do is connect two functions together. So let me show you what I mean before we start it. So basically, let me find the grapher. Here it is. So basically, let's pretend we had, I don't know, first graph is y equals x plus 1, and the next one is y equals 2, right? So what they're gonna do, let's close that there. See the blue one right here is y equals 2. The red, of course, is the line, x plus 1, slope of 1. So what they're gonna do is basically cut off this lower part of the red graph. See how it's, see this intersection right here? They'll cut everything below and then connect it to the blue one. Okay, or they'll delete everything above it and connect this lower red one to the right here. So imagine, I don't know if I can restrict it. That might be better if I can. No, that might take too long. But yeah, so imagine this is the connecting point. So everything above up here is deleted, and everything below this blue line is deleted. So I'll only have all the way up to here, and then it continues on the blue one. So that's called a piecewise function. So they're going to glue this line and this line, delete the excess. So you'll have a bunch of different kinds of functions where they just glue them together, and you need to be able to graph them or figure out in a multiple choice which one's which. Okay, so that's all we're really going to do for 3.2. So let me show you how to do it on paper. Where my example go? Here it is. Okay, so they're going to give you something like this, and say f of x is equal to these two pieces. Right, so it's telling you it is a function. X minus 1 if x is less than or equal to 3. And equal to 2 if x is above 3, greater than 3. So basically you're going to have this line, you're going to graph this line up until you hit 3, and then you switch over to this line, this graph here, and graph this guy above 3. Okay, you just need to know, okay, what do these look like before you do it. So I recommend graphing these on your calculator or the website, or by hand separately and then connecting them. Okay. So I'm gonna graph both of them.
I have a quick question. So I see see what it says.
What's going on? What was your question?
Right before the FX, it looks like there's something written to the left of it. I just can't make out what it says.
Oh, this is just a brace.
No, before that.
F of x equals example 1.
Oh, it just says example 1. I was like, is that part of it? Okay, thank you.
Oh, no. Yeah, that's just separate over here. Gotcha. Okay. So if you're good at graphing, then this will not be difficult. But if you're not good at graphing, then I advise you to use your graphing utilities. Okay. So notice how the important point is 3. So let's draw tick marks around 3 so we can figure out what's going on. So there's 1, 2, 3, 4, 5, 6. I'll need some negative values, -1, -2, -3, -4, -5. I think I won't need that many, but whatever. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so this is how it works. And pretend this is my little XY table for this function. So if I choose a 0 for the X, then you're going to decide, okay, where do I plug it in, right? Do I plug it into the top part or do I plug it into the bottom part? But if X is less than or equal to 3, then you use the first one. So 0 is less than 3, right? So I'm going to plug it in here. So the Y value, which I should probably start using the f of x value, the output, would be 0 minus 1, which is -1, right? If you plug in the 0 here. You guys see that? Right, I'm just plugging in the 0 right there. Now, if I plug in 1, that's still below 3, so that would be 1 minus 1, which is 0. So these are the points I'm going to plot on this graph. So at 0, I'm right here. At 1, I'm right here, right? At 2, we have 2 minus 1, which is 1. So at 2, I'd be there. I mean, we already have enough points to graph our line, right? But the one that we got to double check is the 3. 3 is very important. So if it's equal to 3, we can use the first one. So it'd be 3 minus 1, which is 2. So 3, 2 would be right there. Okay, so we have a line. Make sure everything looks good here. A line going, that's crappy. A line going this way, right? Because it says, as long as we're below -3, or sorry, +3, we're good. So I don't have to worry about anything below. Okay. But now I need to connect this other function. So we got to remember what the heck, what does y equal to 2 look like, right? As I graphed it earlier, that's a horizontal line, correct? So as long as I'm above 3, I will be graphing 2. So at 4, you would be at 2, right? At 5, I'll be at 2. So it doesn't ever change. So this line goes forever above 3 in this direction. Let's see here. But at 3, it's not equal to. So this function is technically not defined there, this line. So it's kind of like a hole for this piece. But the other function is defined there, so that fills in the hole. So the connecting point, is what I'm trying to say, will only be filled by one of them, right? It will not be filled by both, because if it did both, then it's not a function by definition, because you'd have 2 outputs from 2 different inputs. That wouldn't make sense. Okay. So that's all you have to do. You graph one of them, connect it, graph the other one, connect it. So these will guide you as to where do I connect them. You just need to figure out what the heck these 2 look like. Okay. So we go back to our little grapher. I don't know where I put it. Hold on a second. So if I were to graph these normally without the piecewise, right? have this guy and this one. So this part, when it's below 3, here's 3, right? X is less than 3, then I have this line. And equal to, but as soon as I'm above 3, I switch to the constant line. So that's what we graphed. We graphed this part and this part. So piecewise function, meaning your function is coming in pieces of multiple functions. That's what they mean by that. So you just take functions and glue them together. It's just a fancy word for connecting things. Okay. I believe maybe. Okay. So I'm going to delete these here. So I'm going to graph 2 minus 2x. Okay. And x minus 3. So we have two lines. We just got to cut them off depending where they start and where they end. So looking back at the, oops, this is less than -1. So for the green one, we find -1. So there's right here. So I'm going to cut off the green one here and only show below -1. So everything this direction. Okay, so that's going to correspond to these green values, this green line here. Okay, as soon as I get to -1, I have to switch over to the black line. The line would be over here, so it's going to jump from here to there and then start graphing this way after it's equal to or greater than -1. Okay, so that's what we're doing. We're just going to connect them from here and there and delete the rest. Okay, so here we go. Let me turn that off. Okay. All right, so let's make a little table somewhere. I suppose over here is fine. So if I plug in, let's say -3, I'm just choosing that because it's below -1. The only reason I chose it. You could choose -10 if you want, but I want to go too far because then I got to draw more tick marks, right? So -3 would mean I got to plug in 2 minus 2 times -3. So -2 times -3 is a 6, plus 2 is 8. So that is 8. Minus 2 would give me 2 minus 2 times -2, which would be 6. Okay, so let's start putting some tick marks on here. 1, 2, 3, 4, 5, 6. I don't need that many, but that's all right. 1, 2. Let's make -1 a little bit more important. -1, -2, -3, -4, 5. I probably will need more y values. These are bigger. So 1, 2, 3, 4, 5, 6, 7, 8. Hopefully it doesn't go above 8. Okay. Now at -1.
Can I ask a quick question? Sorry.
Yeah. Mm-hmm.
Is it 2 minus 2x?
Yes.
So
that's where I'm getting this here. 2 minus 2x. So I'm using this top one.
So we have 2 minus, oh,
Yeah, so
wait,
two functions, right? 2 minus
yeah,
2x and x minus 3. So I use the top one if I'm below -1. I use the bottom one if I'm equal to -1 or higher.
yeah. No, I think I'm just getting confused on, it's
Mhm.
2 minus, it's 2 minus 2 times -3.
Yeah, so -2 times -3 would be +6. So 2 plus a 6. And so we show our
Oh,
work,
because it
that'd
changes.
be,
Okay, I gotcha.
yeah, exactly. Oops. So we show more work there. That'd be -2 minus a 2 times a -3, which would be equal to 2 plus 6, which is 8.
Got it. Okay, yeah. Thank you.
Okay. And so let's keep on going. -1. If it's equal to -1, I have to use the second function, right? So -1 minus 3 is equal to -4. -2 minus 3 is -5. So -1, let me put some values here. So -1 is -4. 1, 2, 3, 4. -2 would be -5. So it's right there. Yeah. So this line goes all the way down this direction. Oh, no, it doesn't. Hold on a second. Let me hold my horses there. Because it says greater than -1. So I think I got dyslexic on that moment. Hold on a second. Shoot. Yeah, because -3 would be over here. -2, I already used it, so that doesn't make sense. The next one should be 0. There we go. There's a mistake. Sorry about that. I said we have to be above -1. So this would be, the next one, close to the whole number would be 0. 0 minus 3 is a -3. Next one would be 1. 1 minus 3 is a -2. So I redo this little piece. Okay, so -1 is -4, right there. 0 is -2. 1, sorry, -3. Dang it. Forgive me. 0 is -3. So right here. 1 is -2, right here. So it should be -1, 1, 2, 3, 4, 0, 1, 2, 3, 1, 1, 2. Yeah, it's just that my graph is not pretty, that's all. So it should be going this direction. Forever. Okay, so that's the bottom piece. This is the x minus 3 part. Okay, so now let's connect the other one. Below -1, what happens? So we'll use these values. So when I'm below -1, so -2, I'm up here at 6. So 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So right here at -2. -2 is right there. At -3, we are at 8 here. There we go. So the picture will go this direction forever. Okay. Put the graph is much prettier that we used earlier. We go back to it. Just remember what the heck we're drawing, right? So this is the first part I drew, the black line going this direction. And so x minus 2x, x minus 3. There we go. And the blue one at -1, so it starts up here, goes this way, the other one starts down here, and goes that way. Okay, that's what we did on paper here. Now, if you want to use calculators to help you out, or the website to help you out here, that's fine. What I recommend on how to do this is use this restriction that it gives you as your guide. So if it tells you that one of them starts here, then graph things below it, because it says when it's less than, you do this. So start with points below -1. That's why I chose -3 and -2. So now you go this one. So it starts at -1, so I chose that and chose a couple of points after. Then I just connected the dots. That's all we did. Okay. So we're just graphing a few points above and below that restriction. Okay. It doesn't have to be perfect. It's a sketch, but on your homework, they're just going to have a multiple choice. So you're just going to pick which graph is it, right? Oh, one more thing. The way they'll try to trick you on the homework is that this one is not defined. Where is it? This one is defined right here. Come on, yeah, damn pen. There we go. This one is not. You got to double check. Like, okay, how do I deal with this? Because the top line is not equal to. So at -1, you'll have a open circle. And then it jumps down here to -1 and keeps going. See what I'm saying? So on your homework, they're going to have multiple choices. Say, okay, is this one open or is that one open? Do I have a hole there or here? Because they're not connected, so you have to choose which one's open or closed. They cannot both be closed because that would ruin the definition of a function, right? Because if I drew a vertical line through here, I would hit that point and that point, which should not happen. So one of them has to be open. That's why they say this, less than, but over here, equal to. Okay. But I'm not going to make you do it by hand. They should, you can use any tool you want. Okay, so that's example 2. Is there any questions on example 2? Okay, let me find another one. So this function looks like a V. And if you didn't know that, that's okay. So if you know the parent, and this is what I mean when I say parent. So let me calculate. Okay, so the green one is the parent. Now let's use a symbol instead of being weird. So when you see these bars, that means the absolute value function. So what it does is any x you plug in, it automatically makes the output positive. So the green will always output values above the x-axis because it makes it positive. But if you were to add 1 to it, all this is shifted up 1, right? So the parent will look like this, the original. The other one will be shifted. So if I put +2, it goes up 2. Put -1, oops. Sorry, excuse me, fat fingers. -1 moves down, -2. That's all it does. But if it's inside, let's say if it's in here, it'll shift horizontally. So this is a little bit backwards. So +1 makes it move to the left. -1 makes it move to the right. Okay. But if you use your calculator, then you're going to get the answer anyway, which is okay too. I just want to make sure you remember these ideas. Okay. So +1 would just be right here. So you have a few absolute functions in there, but it shouldn't be difficult. If you were to do this using a t-table or something, you would do, to plug in, let's say -2, absolute value of -2 +1 would give me a y value of 3. -1 would be -1 +1. So this would make it positive. +1 would be 2. 0 would just be 0 +1. 1, absolute value of 1 is still 1. 1 + 1 is 2. 2 is still going to be the same as this guy, which gives you that V shape. Okay. But anyway, you don't have to do it this way if you don't want to. Use whatever you like to help you out. Just want to make sure I go over both ways. Okay. So basically, let's do a couple of these. Let's say, is this guy a function? I probably won't even use notation because we don't know yet. So we'll just use y equals. So y equals x squared, right? -3. And they'll give you the picture so you don't have to worry about it. So it'll be shifted down 3. So we have this kind of picture. So yes or no. But if you remember, if I'm able to draw vertical lines through it without hitting it more than once, then yeah, it's a function. You're never going to hit it twice. So you would say yes. It is a function by the vertical line test. Okay, so they'll give you a picture and you just say yes or no. I prefer you justify why though. Let's see this guy here. X squared plus y squared equals 4. So this graph looks like this. Okay. So they're not even going to give you this first time of them. They're just going to give you a picture. But I'm doing it just for the heck of it. It's a very ugly looking circle, but it's supposed to be a circle. X squared plus y squared equal to 4. Now, is it a function? Well, if I draw a line through it, what happens? See how I hit it twice, right? I hit it there and there. This is not a function because it fails the vertical line test. So that's all you have to do on a test. Just draw vertical lines and check. Okay. If I don't give you the graph, then graph it yourself and then check. So first example is write a linear function or cost function for the following situation. So first one, a ski resort charges a snowboard rental fee of $20 plus $4.50 per hour. So formulate a model that can be used for used to determine the total cost, which we'll call C of T, and T is in hours. Okay, so it's not too complicated. Let's just read it and think it through. Whenever you do these, you may need to read it like as many times as it takes. So when I rent a snowboard, it's $20 no matter what. So that's fixed, right? This doesn't matter how long you take. It's going to be $20 regardless. But it's going to be $4.50 per hour. So this guy is going to vary by hours. So this will be the part that's attached to your T. So your cost function, C of T, will equal to $4.50 times T plus $20. So this guy's fixed, and depending on T hours, that'll be the total, right? So if I take 2 hours, it'll be 2 times $4.50 plus that $20. Does that make sense? So they want you to read this scenario and write it in terms of T and C of T. That's going to be the first few questions in 3.3. We'll do a couple more. But for this question, actually, let's do something a little different. So we'll write the linear cost function. Linear cost function, and identify what all the pieces mean. All variables used. Okay, so I'm going to use my own variables here. Still going to be C. I'm going to use C of X. So C of X represents, right? I'm going to define all this for you. Represents the total cost given X time. X is just going to be time. Okay. So the actual equation going to be, so 0.75 for every half hour. So for every hour, that would be $1.50, right? So we should say 150x. So that means that I'm going to have this in hours, plus my fixed cost of $3. Okay, so this represents what's happening. When you plug in your time, you'll get a total cost, C of x, okay? If I were to leave it as 0.75, then x would be in 30-minute increments, right? X represent 30 minutes, not hours. So it makes more sense to adjust. All right, does the notation make sense?
So I don't mean to ask a stupid question. So it doesn't make a difference if it's X or T, they're interchangeable.
Yeah, you define it however you want, or they'll ask you to define it how they want. So if they say T, use T. I use X this time because my T's aren't very pretty. Look like plus signs, and that's confusing. Okay, let's do another one. Find the linear cost function. This time it's going to tell you fixed cost is $300. Items to produce, items cost to produce is $900. Okay, so this time X or T or whatever is not time. This is items. Oh, shoot. I missed something. Yeah, that was like for a second. It didn't seem like we can solve it, but now I see why. So 60 items costs $900 to produce. There we go. Okay. So since they're all linear, this is the general form. So general cost function is going to be C of X equal to MX plus B. So this will be fixed cost, the B. Okay, in real life, B represents the fixed cost if cost is linear, which in this section, they will all be linear, 3, 3. M would be cost per item, or sometimes cost per minute, etc. It'd be like your rate, okay? That depends on the question. So, and of course we said that this guy was total cost. X is number of items, number of hours, etc. It all depends. Okay, Anyway, so we have to figure out the M and the B, right? Just like we did back when we were doing lines, that line section. So we have B though, right? B is the fixed cost. So B will be equal to 300. Now we have to find M, but they didn't tell me what the rate is or anything, but they did say that it costs it costs $900 to make 60 items. So this is actually a point. So when I plug in 60 items, it costs me 900. So use this point to find M. That's what we got to do. So it didn't actually tell us the information. Okay. Alrighty. So let's go ahead and plug it in. So 900 is the cost, right? Because they said that's how much it costs. So we'll set that equal to 900. Items is X, so 60. Just plug it in. So this is what we're going to do. Plug in 900, plug in 60, solve for M. So I'm using this to solve for M. Okay. All right. So subtract 300, divide by 60, and we're done. So M is equal to 10. When you divide this out, right? So the cost function will be 10x plus 300. I got a little messy here. Does these ideas make sense though? Is there any part that I lost yet? I'm trying to put some explanation in here in the middle. So if they ask for your average cost, so if C of X is the cost function, to produce X items, then the average cost per item is C of X equal to C of X over X. So when you see the symbol, little bar on top of the C, that means average cost function. So you find the C function and then you divide by X. That's all you have to do. Okay. So for example, given the following cost function, okay, so let's say it's already given to you. 18x plus 1500. Actually, let's do something else. Let's do this one. 8x plus 1700. So they'll give you the function, and all you have to do is divide by x. So the C bar that they want means you divide every term by x, and that's it. So C bar would equal 2, right? These x's would cancel. That would give you an 8 plus 1700 over x. So that is the average cost function. So right here is finding the average cost function. We'll call this part A. Part B, they may just ask, what is the average cost to make, average cost to produce 500 items? So if they ask something like this, you just have to plug in 500 into the one you found, okay? So really what they're saying is, what is this? And as we said in the function section, that means plug it into any x that you have. So you plug it in here. Oops, no more x. See what I mean? So then just plug it into your calculator. That will be distracted. 8 plus 1700 divided by 500. Approximately 11.4. So you have a few questions where they'll just ask you, what is the average cost of making this, this, or that? So just plug it in. So what I recommend is find this guy first and just plug in whatever number they're asking for, okay? Another way to do it would be to plug in whatever they are asking and then divide your result by that number. If you want to do it that way, you can. It's not a big deal. I did it this way because eventually they're going to ask you, what is the average cost function? I might as well just do it right now. Okay. So same definition. So if C of x equal to mx plus b is the cost function to produce x items, then the average, then the marginal cost will be m. So when you create your function, you just choose the m if they ask for marginal cost. Okay. So let's figure it out here. Find the cost function. If marginal cost is $20, and it costs $5,000, $5,500 to produce 210 items. So again, this is going to be a point, and this is going to be M. Okay. So it's kind of like we did that other example where they gave us the fixed cost B. This time they're giving us M. Okay, so here is our cost function. So C of X will be 20X plus B. This right here is a point where 210 items cost 5,500. So plug that in, right? So 5,500 equals 20 times 210 plus your B. So just solve for B and that's it. It'll be done. So 20 times 210, see what that is. So this will be 5,500 equal to 4,200. Okay, yeah, plus your B. So B will equal, when you subtract that over, 5,500 minus 4,200, which is 1,300. So the cost function will be 20x plus 1,300. So you just need to use the information they give you to figure out what is M and what is B. This is very similar to those line questions. It's just that they're applying it to something instead of being general. So you'll have questions where they'll give you the function like this and ask you, okay, what is the fixed cost? What is the marginal cost? And then they'll ask, what is the total cost of doing something? So you'll have to remember what does each piece mean, right? So it won't be too bad. So that's pretty much half, if not more, of the homework. Let me keep checking here. I want to make sure I cover at least one or two of each type of question before I move on. Means that the revenue function is equal to the cost function. If they ask, what is the break-even point, set R of X equal to C of X and solve for X. So you get a couple of word problems with these. They go on and on about whatever, who cares? But at the very end, they ask you, what is the break-even quantity? What is the X units? So in other words, like let's say, I don't know, yeah, like a taco truck or something, right? And you know how much it costs to make a taco, and you know how much money you sell that taco for. So you have to sell a certain number of tacos before you break even. And after that point, it's pure profit, right? Because first you got to pay for the cost. So whenever revenue surpasses costs, then you're in the black, right? If they're equal to or less than, then it's going to be red or breaking even, right? You're going to be losing money. Anyway, so they'll have some scenario and they'll give you a cost function. So for example, find the break even quantity given C of X equal to 360X plus 11,520 and revenue function equal to 480X, right? So what I want you to understand is this is how much money I make. This is how much I sell them for, right? Let's say, I don't know what it is, but every time I sell one, I get $480. But it costs me $360 to make one of them. And then I got to pay a fixed cost. So like, let's pretend we're selling expensive tacos, right? Who cares? It takes me 11,520 to set up. Now this could be like buying ingredients, buying your truck, whatever, who cares? This is what I'm selling them for. So I need to sell quite a bit until I pay off this startup cost. And I'm also losing money each time I make one because I got to buy ingredients or materials or whatever the heck we need, depending on what we're doing, right? So that's the idea. Money comes in, cost to make that item, price to sell the item. So break even will happen. So set C of X equal to R of X. So this would give us 360X plus 11,520 equal to 480X. So solve for X. And it doesn't matter which side you put them. So you could put revenue first, equal to costs, whatever. Doesn't matter. So I'm going to subtract 360 over here. Yeah. Yeah, that's fine. So minus 360. So if I move it over there, across the equal sign, it turns into negative. Or I subtract both sides by 360, however you want to think about it. Doesn't matter. 480 minus 360, that will be 120x. And then divide by 120, and we should have the amount of units that I need to sell or make to break even. So divide by 120. Divide by 120. Okay. So 11,520 divided by 120. Oops, with times. There we go. So this will be 96. This is what X is equal to. So when I make 96 tacos, I will finally break even and pay for the startup cost or the fixed cost, whatever that is. Again, this is just a general scenario, but X will be the number of items I need to make or sell or whatever. Okay. So if you're out there selling stuff and you don't hit 96, then you're going to lose money because you had to pay that startup amount, right? Or if you don't sell enough, then you'll be negative, which would be a problem. So you want to try to be above the break-even point, because that's when profit begins. Is there any questions about this idea, breaking even? Find break-even point. Part D. Let's see here. Okay. Decide if the company should go ahead and produce this product or item, I guess. Okay. All right. So it's hard to decide whether or not we should, because we need to find out that break-even point. If the break-even point is larger than 666, then that tells you for sure, we should not make this, right? Because you'll never break even, and you'll lose money every single time. That would be silly. Makes no sense. So let's do part A first. So there's my cost, there's my revenue. So set them equal to each other and solve for x. So that would be 135x plus 4086, 0, is equal to 180x. Okay, so subtract the 135 and then divide by whatever we get. And so here we go. Okay. Subtract. So the 180x minus 135x, which will be something. And then we'll divide by that on both sides. Divide both sides by 45, it looks like. Interesting. So the break-even point is going to be 908. So should we make this item if I'm limited to 666? We should not make this because 908 is greater than the limit of 666. So I will never break even if I'm limited to this amount. It would not make any sense. So you would tell your company, yeah, don't do this. Either make something else or find a way to reduce cost or a way to hold more items, whatever it is. Right? So that's how you would start your analysis. Do you have any questions on breaking even so far? Okay. One last thing. I don't think it'll come up, but just in case. The profit function is equal to the revenue function minus the cost function. Just in case they mention, if they give you profit, just remember it's equal to this, okay? So they give you profit and they ask you to find revenue, you would just add the cost to the profit, right? That would give you revenue. If they give you profit and they want to know cost, well, you'd have to solve for cost. You might have one of those, but that's not too bad. Just use the formula and you should be okay. On this guy. So to solve any quadratic equation, doesn't matter what it is, the first step is set it to 0. So step 1, set it equal to 0. So you can skip a step here and there as long as you show some steps. So you could just move the 10 over and say, okay, now I'm ready for the next step. Or you could say, you know what I'm going to do, you could also write minus 10 on both sides and then get to here. So it's up to you, as long as you show this step and then that step. And the next step would be, once it is set to 0, factor. So the next step, you'd use whatever factoring technique is appropriate. So for this guy, I would recommend using the AC method, but if you use something else, I'm not going to take points off as long as you get there, because you do have to show work. So A times C would be this A, that's C, so you'd get 7 times negative 10, which is a negative 70. Calculator's in my way. Okay. So that would be negative 70. So then you just got to find the factors that add up to the middle term. So it's quite a few. Let's see here. Obviously there's 7 and 10, but that's not going to work. What else? There's negative 2 and 35. There's 2 and negative 35. And if sometimes you can't think of any more, you can try using our calculator to help us. 70 divided by, let's say, 4. Nope, that doesn't work. 70 divided by 5 works. So I would write negative 5 and 14. 5 and negative 14. Okay, and let's go to the next number. 70 divided by 6 doesn't work. 70 divided by, well, we know 10 does. 8 does not work. 9 does not work. 70 by 11. Nope. 12. Looks like, double check here. You said 2m, right?
Yeah.
Okay. Just making sure. All right. Oh, 14 works. Okay. Yeah, I already did that. Okay. I'm missing one of them. Can't seem to remember. So we'll keep going. Something seems off. if you can't find a factor, that means this method is not going to work, which means we have to default to the quadratic formula. So there is no factor that's going to add up to -2 that I can find. So I just cycled through many factors and it didn't happen. So sometimes it happens, and you're allowed to use quadratic form anytime. So the formula is written as this. I'm going to use m instead of x. This will be -b plus or minus square root of b squared minus 4ac. Everything divided by 2a, right? So a, over here I use capital A, so I'm going to rewrite that because we should be consistent. A times c. So a is 7, b is -2, and c is -10. So I have no choice but use this method, even though I don't want to. M will be -b plus or minus the square root of -2 squared minus 4 times a times c divided by 2 times 7. Okay, so that will be 4 plus or minus 4 minus, so -2 squared is 4. -4 times 7. So let's just do this all together. -4 times 7 times -10. Positive 280, so plus 280. Everything divided by 14.
Quick question. How did you get the m equals 4 in the very beginning part?
Oh, shoot, that should be a 2. I have no idea how that happened. Thanks.
Okay. Yeah, no, I just wanted to make sure I didn't miss anything.
No, that was a mistake. All right, so 2 times 7, -2 squared is 4. This we just did right now. Looks good, yeah, okay. So this will become 2 plus or minus the square root of 284 over 14. Now, I doubt that's a perfect square, but we can hope. Nope. So to reduce a square root, we said we need to find squared factors. So just cycle through squared numbers. So 4 works. Okay. Pretty sure that's the only one we're going to use. 9 is too big. 16. Nope. So what we're going to do is rewrite the 284 as 4 times, we got 71 from the calculator. Okay. So now that 4 will come out as a square root of 2, right? Square root of 4 is 2, rather. 71 will stay because that is not square. So now we have 14 right there. So we can reduce the top and the bottom because they're both divisible by 2, right? These pieces here. So when you factor, then you are allowed to cancel. So I'm going to factor a 2 from the top. So it leaves you with a plus or minus root 71. On the bottom, I can break down the 14 into 2 times 7, right? Just like it was at the beginning. So 2's are gone. So our answer will be 1 plus or minus root 71 divided by 7, which is the same as 1/7 plus root 71 over 7, and 1/7 minus root 71. You can keep it this way, not a big deal. If you get to, let's say you get to here and you're kind of not sure how to go further, I mean, I'll give you the majority of the points because you recognize I should use quadratic, you plugged in everything correctly. But if you get lost on the simplification, I'm not gonna write the whole thing wrong. I'll give you at least more than half credit at this point. Okay.
Okay, do you mind going down from that 2 steps down where you have the equals 2 plus or minus 2 square root of 71 over 14? That's the
Over
one, right?
here?
Yeah. So from there, can you go over that step again where how you got 2 times 1 plus or minus 71?
Yeah, so you square root the 4. Square root of
Right.
4 is 2, so it comes out in front.
Okay.
So this is now a product, 2 times that.
Okay.
So whenever you have, like, for example, square root of 12 is the same as square root 4 times 3, right? So what you can do
Right.
is square root the 4 and square root the 3 separately,
Mhm.
which ends up as a 2 root 3. So that's what's happening here.
Okay. And then the next step?
Mm-hmm. Next step, they have 2 in common. So like if you had, let's make a little scratch word thing. Let's say you had like, I don't know, 2x plus 2. You'd say, well, I can pull out a 2 out of it. So I'd have x plus 1, right? They both have a 2. So I factored a 2 out. Does that make sense? Don't let the plus or minus bug you. It's just some operation, and I'm pulling out a 2 from both parts. Okay? As long as it's plus or minus, either one, you can do this. Right? Like if it was 2 plus 2 root 71, you would just pull out a 2, right? Do you agree?
Okay, I think so, yeah.
Because you can't combine these. And this is kind of like a 2x or something. These are not the same. So,
Gotcha. Okay. And that's why in the bottom step you took apart 14 to 2 times 7 so that you can X out both 2's,
yeah,
right?
so they'll divide out here. 2 divided by 2 is
Okay.
1, so it's gone.
Right, right. Okay, gotcha.
It's like when you have fractions, right? Like, I don't know, 4 over 12. Technically, that's 4 over 4 times 3. So you get rid of those 4's.
Mm-hmm. Yeah.
It's the same type of deal. But you only cancel numbers once it's factored. You do not cancel if it's not factored. Like, for example, I couldn't reduce this 2 right here. This 2 and that 14, I can't just cross those out because there's no 2 in front of the root. So I'd have to be able to factor that first, which didn't happen until later.
Okay. And then when we go all the way to the end, we have to put in there 1/7 plus the square root of 71 over 7, and then also we have to do the one that's subtracting it, right?
Yes, I mean, you don't have to write it this way if you don't want to, but I just wanted to write it so you know you have 2 different answers. That's what this represents.
Okay, got it.
Okay. And if you were to punch this into your calculator, you get 2 decimals. So those are 2 locations that make this guy 0.
Okay.
Let's see.
So I guess maybe in the other one that I gave you, maybe I just didn't write it down, but maybe it was already equal to 0.
Yeah, we can try it, see if it works. And if yeah, that's fine. Let's try that. But 1 second. I want to show you something. Okay. So if we were to graph this guy, right? This is the question you gave me. I just moved the negative 10 over, right? So we did at the beginning.
Mm-hmm.
And we set it equal to 0. So if y is 0, then that means that you have 2 points two x values that make it 0. So graphically, it has to be the points that touch the x-axis, right? Because that's what it means. Y0 meaning I'm hitting these points.
Mhm.
So this negative 1.061 is actually the 1/7 minus square root 71/7. And this one's the plus.
Mm.
But they're using, of course, these programs are using approximations. So we have an exact answer. They have an approximation, which is whatever. If you plug it into your calculator, you can get those numbers too, using a scientific. But visually, this is what it means.
Is that called a vertex? Or what is that called?
The which one? I'm sorry.
The type of graph or the type of what came out of that anyway? Is that what is
Oh
that
yeah.
called?
Oh yeah. The all quadratics like these with the x squared are called parabolas. Yeah. So they're all gonna have that shape, like a U, kind of like a curved U.
Okay.
Okay, let's do that other one. Do you remember what it was?
Yeah, it was 3x squared
Okay.
minus
Minus.
5x
Mm-hmm.
minus
Okay, so we'll set equal to 0. So at first glance, I'm hoping that we can use AC method. So A and C would be 3 and negative 7, which is negative 21. So factors of negative 21 that add up to negative 5. I don't think there is one. So there's only what? 3 and 7. There is no other one other than 1 and 21. So it looks like this is going to be another quadratic formula. But let's look at it visually before we start, just for fun. Okay, let's see what the parabola looks like. So we have 3x squared minus 5x minus 7. By the way, when you do powers, you got to do the shift and then a caret to go up. Anyway, so 0 are right there. So these are the numbers. So as you can tell, they're not pretty numbers, right? So they're going to be most likely fractions or square roots with fractions. So that tells me graphically that quadratic formula is the best way, because you get pretty numbers when you do all those other factoring techniques work. And since they're not working, I expect these solutions to be weird looking. So let's go ahead and start the quadratic method here. Formula. Okay. So here's our formula. X is equal to negative b plus or minus b squared minus 4ac over 2a. Okay. All right, so let's plug them in. Negative, negative 5. Oops, sorry, I got distracted. Okay, so negative 5 squared, because that's the b, minus 4 times a times c. There we go. Okay. All over 2a. So you guys are comfortable with the formula, or no questions about where these numbers are coming from, right?
Yeah.
Okay. All right, so negative b, here we go. This becomes a positive 5. This becomes a 25. Well, let's find out. It's going to be plus because we have a negative and a positive and a negative. So negative 4 times 3 times negative 7. So that would be plus 84 over 6. Okay. 25 plus 84. That will be 109, which is not a perfect square. You can tell right away. But just to be safe, I'm going to check. No. So before we go any further, we got to check, does 109 contain any squares? So does 4 go in there? Nope. So I'm going to choose the next square, 9. Nope. Next square is 16. Nope. Next one is 25. Next one is 36. I'm like 90% sure that you can't factor 109 after using that big of a number. If you want, if you're paranoid, you can keep going. After 36 would be 49. But yeah, that's not gonna happen. Next one is what, 81. So at this point, yeah, you would just stay here. That's it. It doesn't go any further. So you could write it as 5 plus 6 plus square root 109 over 6. Oops, sorry. You can separate them together. Doesn't matter. I would just take this guy, honestly.
Okay.
It's not a huge deal. At this point, you've done everything I wanted. You're just kind of making it prettier or different. You know what I mean?
So
But what I want to see is you identify ABC, you plug them in, and you simplify as much as you can. If you don't get all the way simplified, you'll still get majority points. Okay. If you
so
make an error here, it's not a big deal.
I noticed your very first approach was 8 times C. Is there like an identifier that you look for to go that route initially?
Yeah, let me share some file with you real quick. Actually, it's a good question. Where is it? I think it's this guy. Yeah, here it is. My one of my coworkers, his teacher made this. His name was Michael Jackson, but it wasn't the Michael Jackson, just a Michael Jackson. But there you go. I'll go ahead and open it so you can see on my screen.
Okay.
It's a flow chart as to when do I use which technique, right? Because there's quite a few techniques, as you've seen. Let me share. There you go. I recommend downloading that and saving it. You can use that for your tests. So the first thing you do every single time is check, is there GCF? This is for factoring, right?
Mm-hmm.
And then you count, okay, there is none or there is, and pull it out. Then I count, do I have 2 terms, 3 terms, or 4 terms? If you have 2 terms, you will have only really 2 options, a difference of squares or one of the cube formulas, okay? You can usually tell which one's gonna be. If you have 4 terms, you automatically start doing grouping, factor by grouping. If you have 3, I first check, okay, well, what's the number in front of the x? So in our question, we had a 3x squared. So since it's a 3 and not a 1, I do not do trial and error. I instead go to AC. You could force your way with this. Some people do that, and that's okay. But I don't like to do brute force. So I'll use the method that works every time. Perfect square, you'll use this if you notice that the first term is a square and the last term is a square. Then you can probably jump to one of these formulas. Although if you don't notice that and you attempt to do AC, it's still going to work out, and it's not going to be a huge deal. You just end up getting two of the same pieces. Then at the very end, you check, can I go any further? If not, then that's it.
And you said we can save this and even if we're sharing our screen, we can go into some save files that we have.
I might have to change a setting. I think it might lock you down. Let me check. Yeah, I'll let you use what's it called? Different files, because I don't want to force you to print things. And also the grapher is a website, so.
Right, yeah. And that's desmos.com, right?
Yeah, just Desmos, yeah. Exam 1. Yeah, I'll try to mess up it later. Make sure it's you can do that.